Unit 3.5. This is the final one before we do a project. In Unit 3.5, we are dealing with strings. Like I promised, we would end with strings, all about strings. The first thing is strings are immutable. That means you can't change them. They're unchangeable. A string is an immutable sequence of characters, or strings are immutable sequences of characters. So a string is made up of characters. That doesn't mean that it spells a word. It just means that it's a character. So it could be an exclamation, it could be anything. Anything that you have on your keyboard put together forms a string. Now, the string has two ways of creating it. Okay, the literal way, you could put the quotes, okay, or you can use the constructor. We've seen this before. So I'm making two strings here, one called class description and one called class description 2. All right, speaking of naming variables, if you have variables that have somewhat similar name, but you want to find another way to say the same thing, you could put a little number here to separate them. Can't start a variable with a number though. Okay, that we can't do. We can't put a 2 in front, but we could definitely put it behind. So this string class description is a string literal, and it has exactly geometry is a good class, and then it has a constructor with the literal inside, new instance of a class. So I'm creating an object. We've seen this before. This is immutable, just like the wrapper classes, integer and doubles and so on, uppercase integer, uppercase double, and character and boolean and stuff. So this string here that we have, we're going to be working with this. Now, we are going to look into the string API, application programming interface. So the string API has a lot of methods. Now, the thing is, every method that's in the string API is not what we are going to do. I'm going to show you a number of them, but we're not going to necessarily do all of them. Okay, so this list is by no means exhaustive, but it is a good list. It's a list that we should pay attention to, because these are some of the things that we want to figure out how to use. So for example, the method length finds me how long the string is, how many characters are in the string. Character at I, given a number here, it will tell you what letter is at that spot. Substring ij, it's part of the string starting at I and stopping at just before j. And then we have substring I. There are two ways to do substring. This is called method overloading. Two ways to do the same thing. Start, stop, start, and to the end. This one says from this position to the end of the string. This one says index of. Give me something here that you want me to find the index of, and I'll tell you where it is in the string. Equals. Tell me if these two strings are the same. Compare to. Compare these two strings and tell me where they fall lexicographically. That's a fancy word. That's a fancy word, but we'll see what that means. So moving on to the API methods and looking at them in a more visual way, I'm going to look at these two, index of and character at. So when you do index of and character at, you have to put the letters for the string, and speaking of the first string here, geometry is a good class. And I'm writing out geometry is a good class, but you realize I have some boxes around them, because what I want to do is I want to number them. Okay? We want to number them. Early in the course, when we were converting bits and hexadecimal and so on, I say computers always begin at 0. 2 to the 0 was the first bit. Same is true here. We start at 0. So the G in this string is at position 0. And of course, the E is at position 1, and this is at position 2, and then 3, and so on. So that's the reason why you see me have them all here, because I want you to realize that a string is a sequence of characters and they're numbered. Yes, they are numbered. So every single character in the string has a spot, even the space. See, after geometry, the space also has a spot. He's at position 11. there is another space after is, and he is at position, sorry, first space is at position 8. That's an error. First space is at position 8. And then the other one, which is the is right here, then you have another space here is at position 11. And so even the space has a value for it. Every character has a value. Okay. Now, because I'm labeling this 0 through some number here, you should realize then that this thing has 24 characters, okay, including the space. So this 23 doesn't say it has 23 characters, it has 24 because we start at 0, not 1. This is good for character at an index of. So what do I mean? Suppose I say, what's the index of the letter M? Well, we find the M here, and it should tell me it's at position 3. What's the index of uppercase G? It's going to say 0. Now, one thing with index of, it finds the first occurrence. So if a letter repeats, it's going to find the first time that letter occurs. So if I say what the index of S, well, there are a lot of S's. There's an S here for is, and there are 2 S's down here for class. Which one would it find? The guy at 10. Okay, it's going to find the 10 because the first S in geometry is a good class. Character at is a specific position. So if I say, give me the character at 15, where you look, and you find 15 and say, oh, that was an O. Give me the character at 5, you look for 5, and you say, oh, that's a T. This will return or send back a character at that position. Just like we write those methods in there where we had a J panel and then we returned it. This is going to have a method that return the answer that we're looking for. So I have to say character at, and a number goes in here. If I say character at 12, it's going to look for 12, and it's going to send back an A. Okay? So index of tells me where it is, but character at tells me what that value is, or that character is at that spot. The other one that's important is substring, and this is the one that's down here. Substring is a little different to this because there is this half closed, half open interval, right? So if you don't really know math too well, this one means include. This one means exclude. So we start at I and we stop at the value just before J. That gets a little bit confusing, writing it mathematically. So we have a visual representation. The way to do substrings, and this is specifically substrings, okay? So this visualization is for substring, this visualization is for index of and character. 2 different ways to express the string here. The reason for the lines between the letters in this one is such that when we do IJ, we could include both, okay? We could include both and it will be perfectly fine. So what I'm going to do then is, let's say I said, give me the substring of this thing. So I'm going to say class description dot substring, and I'm going to go from 0 to 2. If I go substring 0, 2, it's going to give me GE because it starts at 0, stops at 2, and it gives me that part of the string. That's what substring means, part of the string. So if I say class description dot, okay, it's an object, dot, give me the substring 3, 5, it's going to return me. ME. From 3 to 5 gets me ME. If I say 5 through 8, it's going to give me try. Okay? So the neat thing about substrings then is that we can get a word within the word. Or we can get a string within a string. Like, for example, I can find the word try. Okay, I could find the word try. I could find other words that are not so obvious also. Okay, I can find the word glass. How come? Find the G and find the LASS and concatenate them. Put a plus. Remember, it's a string. Put them together. And I got a glass. See, within this string, I can find other strings. And so, what I want to do then is I want to go through some of these methods and see what we would get when we run this. So let's just take a look here and see what we have. So paying attention to this visualization, is better to visualize it and understand. If I say, hey, system.out.print class description.length, it should print 24. 0 to 23 is 24. What if I say print character at 14 plus concatenate, put them together, substring 20? Okay, so let's see what that gives me. Character at 14. We got to look for that up here. So we find 14, we get G. Okay, G. And then I say, hey, class description substring 20. That means go to position 20 in the substring. So I'm looking down here. I'm looking down here. So look for 20 and go to the end. Remember, when you have one value is where it starts from and then go to the end. So I have LASS. Put that together. What do you have? Glass. Now, I have class description substring 5 through 8. So 5 through 8. Try. That's 5 through 8. Then I say class description, give me the character at 8. Well, character at, I'm back up here. So it's a space. So I have try plus a space plus give me 3 to 5. 3 to 5 is me. So guess what that prints? Try me. Now I said, hey class, give me the English of ODD, odd. Well, we got to look to see if there is such a thing. I see an O, I see a D, but I don't see another D. So this does not exist. So you know what it sends back? -1. Whenever we have an index structure or anything indexed in computer science and it's not one that exists, so we're looking for odd and there is no odd here, it's going to return -1. Okay. This one says give me the index of the O. There are a lot of O's. Okay, we can't look down here because this is the substring. We got to look up here because we're doing index of. So if I'm looking at the index of O, it could give me either 2, scanning, 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 15, 16. Well, it's going to give me the first one, 2. And then it says classical index of MET. MET happens right here. We found it, so it's going to give me 3. Okay, that's where it starts. First index, first. Then it says, hey, class description is equal to class description 2. Should say yes. They both said geometry is a good class. What's the index of try? Well, we look at try here and it should send me a 5. And then it says, hey, give me the substring from 0 to the end. Well, that's going to give me the whole thing. And that's not up here. That's a thing. It's going to give me the whole thing. Substrings down here. 0 to 24. That's the whole thing. If I say give me 0 to 24, it's going to give me. So these two are the same things. Okay, these two are the same because this one says go from the beginning of the substring to the end. So it's going to go all the way to 24. This one literally says go from 0 to 24. What about this one? Well, this one's not good. 30 doesn't exist. 30 is somewhere out here. We don't have anything out here. So guess what's going to happen? It's going to crash the app. It's going to crash the app. So let's go ahead and run this and then let's see the crash. It's going to say the index is out of bounds. Okay, so let's go ahead and look back. So these are all the numbers we had from before. You see the true. Remember that those strings from before turns everything into a string. Here we go. Geometry is a good class. So we have this geometry is a good class here in the 0. Geometry is a good class again. And then it hits this guy and we crashed. And what did it say? Out of bounds exception. It means the 30 is out of the numbering here. This is 0 to 24. anything with 0 up to 24 integers, then that's fair game. But once we go outside of this, either on the left, -1, or beyond this, 25, 26, it's going to crash. So I'm going to go ahead and comment this out because I don't want my app to crash. This is bad code. Let's call this bad code. Okay, we're crashing the app here. All right, so that's pretty much how these methods work. You give the object dot method, and then we go down and we see some more methods, but these methods are a little bit more powerful than the ones we just saw here. For example, compare to. It compares it lexicographically. Fancy word for kinda alphabetical. Now, the reason I'm saying kinda, it's because it's not truly alphabetical. Since a character could be anything, it might be a character that's not in the alphabet. So that's where it gets a little tricky there. But also, most of the time when we're using a string, we're going to use it as an alphabetical value, meaning it's going to be an actual name. So in a way, we're going to consider kind of alphabetical. So, we want to compare two strings. What if one has an at or an exclamation? So those things are not in the alphabet, so we can't alphabetize it. But in general, when I say kind of alphabetical, it means if the string has only regular words in the alphabet, in the dictionary, for example, then when we compare them, it's going to say which one comes after the other if you were to put them in alphabetical order. So one tricky thing about this, though, is that uppercase and lowercase letters are different in computers. So that means then that's why the lexicographical is also in there, because an A is not an A. It depends on if it's an uppercase A or lowercase a. There are two different ASCII. So when we see if the two strings happen to be exactly the same, it's going to return a 0. Compare to returns an integer. 0 means the two strings are exactly the same. They have the same characters in the same spot. If it sends back a negative, it means the guy in the front comes before the one in the second spot. And if it sends back a positive, it means the first guy comes after. And if you think in alphabetical, then the guy in the front would be further down in the alphabet. That's what after is. And the guy, when it says before, he comes earlier in the thing. So here are some examples. Hello dot compared to hello. Well, that's different. Because the way the alphabetization of this thing works, this lexicographical order, uppercase A comes before lowercase a. It's all the uppercase letters all the way to Z, then the lowercase letters all the way to Z. That's the order. So hello, uppercase, should come before hello, lowercase, because the H is going to be down here, right, in the lowercase letters, and the H is going to be over here in the uppercase letters. Hello dot compared to hello, both hellos the same, it's going to say 0. And he dot compared to hello, he should come before. Okay, so we have this idea of before and after, and then I'm going to run this to see what we get. So let's run it, see what we get. So at the very end here, we got these 32, -32 as a 0 and a -3. So we got the idea of negative being before. Make sure we get that. Okay. So what does that mean? That means that this guy, if we were to put it in alphabetical order or lexicographical order, should be put before this guy. And he should be before hello. Now here's the thing. Before turns out to be negative, so I don't want to get into the exact reasoning why, but it has something to do with their values, okay? Their ASCII values. They do a subtraction and so on and so forth. So there's, like I said, every value, every character has a number. So this could be calculated, okay? Just keep that in mind. Don't want to get into the specifics there, but since every letter has a number associated as an ASCII, that's what we did earlier on, it's quite easy to figure out that there's some kind of calculation that's possible. And so we can figure out which one comes before and which ones come after, okay? Now here's some other useful methods. We have two uppercase. If I say, for example, let's go back, hey, class description dot to uppercase, it's going to turn this into all caps. Okay, let that one sink in. Yeah, the API is powerful. That's the reason why we need an API, because if you want to turn something to all caps and it's a string, just do dot to uppercase. And if you want to get it to all lowercase, of course, you go to lowercase. Trim says take off any spaces that came before and after the string. So if somebody puts a space in the string and then a space after the string, take those things out. The space in between stays, but the space on the outer ends could go away. Is empty. Is this a string without anything in it? And if you're wondering, well, how does a string look with nothing in it? Like that. Is it an empty string? We call that an empty string. If it is, this thing returns true. I told you this. Is Boolean. It's either empty or not. True or false. 1 or 0. Okay? Then we have this replace. Old character, replace it with a new one. So go into the string and replace the E with an A if you want to do that. And then this one replaces 1. And then we have replace all. So we have these. Then we have it starts with. You have all these methods that you could use and ends with. Is it true that this thing starts with this prefix? Does it end with this prefix? Or suffix, I should say. So these are good methods. I mean, we're not going to do a lot of these all the time, but these are just good methods to know and to use in case we're writing an app and we need to use them. So now we have an exercise. And I'm going to do the first one, right? And you are going to do the rest. So when this video is over, your job is going to be to continue writing the code to do the rest. And what do I mean? These are string literals, and I want to print them. But I want to print them by using the class description. Same class description that we have above. I'm copying it, putting in the visual here next to this so that you can see it as you write your code, okay? I'll walk through the first one. I'm trying to print I am tall. And you may say, well, there is no I am tall in here, but there's a way to come up with I am tall. So, and there's not only one way to do this. You could do this any way you want to and experiment with it and play around, but I do need to use character at and substrings because I need the actual letter. Index of won't help me here because index will just tell me what position it's in. So I want the actual letter. So character at and substring is all you're going to use to write these. Okay, you're going to do 2 through 5. When this video is over, you're going to sit down and write me the code to do this. Now, all of these are going to be print ln. So print ln. So here we go. Class description dot substring 9 through 10. Let's see what I get here. That gives me an I substring. So I'm down here. Then I say, hey, dot to uppercase. I just turned the I into an uppercase I. So I have this. I'm concatenating plus class description dot substring 89. Let's see, substring 89. That's right here. That's a space. I did that guy. Now I want am. So I say plus class description character at 12. Well, I'm up here now. So I'm looking for 12. I got an A. Plus class description character at 3. That's up here. So I got I am. I need tall. So I have the space as well. I have the space, and I have am right now. So plus character at 8. Well, character at 8 happens to be a space. You see how I did that 2 different ways? The first time I did substring 89 was a space. Then I did character at 8, which happens to be a space. So I'm kind of bouncing back and forth between these two. All right, so then I go plus character at 5. Let's see, I'm up here, so I have T. See, I'm starting to do the tall. Okay. Now I need the A and the L and the L. Then I say, hey, character at 12. Well, let's see, that's an A. And then I had a character at 20. Happens to be an L. And I say, hey, give me another character at 20. And I got tall. So if I run this, you'll find I printed I am tall. So your job is to go through and print, try to get good rest. Meet me at class. It is oddly a game, and I am last to get a retro style. Just from this. So it's going to be one statement. It's going to be long. You're going to have a lot of concats. And you could do it letter by letter with character at or substring. Or you could do all substring, all character at, or you could mix them like I did here. Okay, sometimes I did substring, sometimes I did character at. And I'm just going to go ahead until I get this entire thing. Remember the spaces. Don't forget the space. And that's going to be your assignment, okay? This is something you want to do. It's not for a grade, but it's something I'm going to check to make sure everybody finished, okay? So when you get to this section, once you're doing this in class, the idea is to go ahead and continue doing this until you do all of these, okay? So at some point, I'm going to stop and say, let me see your strings, let me see your substrings, let me see your characters, and let me see what you got. So make sure you do them. It's good practice as well because you're working with strings. And again, we're going to work with strings. I told you, most powerful data type is strings. Started with that, and we're going to end with that. We're going to work with strings all year long. So it's might as well you start practicing. 3.5, all about strings. That brings us to the end.